Welcome everyone to my presentation about the computational modeling of transformational organizational change with a focus on organizational culture and learning. It became more and more apparent that there is an urgency to adapt our systems and organizational structures to the changing circumstances of the world and learn how to facilitate sustained change. Organizational culture is a priority nowadays, especially the constant improvement thereof in the context of healthcare, as COVID-19 is putting further pressure on public healthcare systems. The concept of healthcare safety culture is closely related to a constant learning culture, which is composed of components as like learning climate, mistakes acceptance, and forms a part of a constant learning process, or also a constant learning culture. Furthermore, the classical understanding of organizational change, those that we are trying to perform, is that organizational change is an external process that can be applied to any organization. However, some research should suggest that we shouldn't view it like this, but that we should view organizations as complex adaptive systems in which organizational processes are dependent on the interactions of independent individuals. So change isn't an external process that can be applied to an organization, but change is an adaptation of that system. However, computational modeling and formalization of organizational change and learning processes are still largely unexplored. Therefore, we want to provide an adaptive network model of transformative organizational change and translate selection of organizational learning and change processes into computationally modeled processes. The literature review therefore showed us some interesting suggestions and facts. The systems model of organizational change, for example, proposed by Mas and van Holtkamp, proposes to view organizational change not as a linear process, but as a multidimensional mechanism. So using multiple mechanisms at once instead, and multiple dimensions, organization dimensions at once, instead of just applying it as an external process. Further, organizational change is significantly influenced by organizational culture. The culture here, the culture of an organization, is mainly shaped by its members' shared values, norms, assumptions about reality, and learned behaviors. In this context, constant learning culture aims to provide an environment for sustained learning possibilities on both the personal and the organizational level, for example, through mistake acceptance and the collaboration-driven organizational culture. We also found and reiterate that organizations can be seen as dynamic adaptive systems based on individuals' actions and processes of action and sense-making. In this systems perspective, transitions processes are emergent of the interplay of various actors pursuing their interests. Their overall direction is usually driven and propagated by actors with a larger plan or vision in the context of organizations, usually leaders. Transformational change here is characterized by the reshaping of strategies and behaviors, as well as a shift of values and culture. Organizational learning usually in this context takes place by feed-forward learning, in which information and processes get propagated towards higher organizational levels, and feedback learning, where changes on the organizational or team level get propagated back towards lower levels of the organization. However, after having performed an extensive academic background check, we found that there's too much information, too much theory to all adapt into one model, which is why we focused on a research focus. Here, I'm going to list the three main elements that we're going to focus on. First, we're trying to confirm if the explored dynamic systems view of organizations can be translated into the self-modeling approach by Troyer. Secondly, we will try to verify if a shift in learning culture happens towards a constant learning culture within the model. And thirdly, we want to explore different organizational learning mechanisms, effects, and their effectiveness in correcting inaccurate mental models or organizational processes. Here, We want to first test feedback and feed-forward learning. We want to test learning from mistakes in context of diet learning. And we want to gauge the effects of leadership-inspired, instruct organizational cultural change incentives, for example, workshops or restructuring of teams. To create that site computation model, we follow the computational network model, adaptive computational network model approach by Troyer, which is based on connections between different states that are translations of real-world causal relations into a network structure, and the weights of those connections, the timing, a speed factor that represents the rate of change of those states, and aggregation functions that determine how multiple inputs to a node are combined. Further, adaptivity in this context is modeled through higher order self-models, also called replication states, that enable adaptivity and reactivity of weights, speed factors, and networks characteristics like the parameters of combination functions. Based on an established case and the academic background research, we therefore created a network model. This shows the base state and the first order. On the base state, we can see the mental models of all individuals and organizational levels, 4 young doctors, 1 experienced doctor, 2 team shared mental models, and 1 organizational shared mental model, as well as a world state, as 3 world states in which the task actually is performed. The scenario we're trying to model is a healthcare-related 3-step task in which each step should succeed the next. So task 1 should happen, then task 2, then task 3. However, mental models and knowledge can be faulty. Therefore, in this case, there's a possibility that step 2 gets skipped. However, we want to try to model in our scenario, in our model, how we repair this faulty knowledge, how we repair mistakes happening through different mechanisms. For that, the mental model representations are on the base level. On the second level, the blue pane, the connections between the tasks are represented by the weights, so we can adapt these. And between the weights of the different meta models connections are interactions or possibility of interactions given organizational learning from mistakes, or other processes and mechanisms. Here we can see the first and second order. The first order, again, the blue pane, shows the weights of the mental models connections. And the second order, here in the purple pane, show the different organizational mechanisms we apply to the base scenario, to the base model. In yellow, the error detection and being proactive about an error mechanism is depicted. This should insensitize young doctors, instead of hiding their mistakes, to be proactive about it, to register them. In orange, the actual learning from mistakes mechanisms through diet learning and reflection is modeled. In green, the daily shift reflection meetings are modeled, in which young doctors and experienced doctors together will talk about the happenings, the mistakes that happened during the daily shift, and will reflect upon it and learn from it, formulate lessons, and propagate them throughout the team. The same happens in the purplely highlighted mechanisms, which depicts, however, monthly company-wide meetings in which the same process of feedback and feed-forward learning happens, but on the grand scale of the organization. In light red, we can see also the mechanism of reshuffling or like restructuring teams, which has an effect on some of the parameters of the combination functions of the young doctors. The turquoise part of the mechanisms are internal control mechanisms for the model. We have run simulations based on this model, and an overview can be seen on this slide. Generally, it is very cluttered, and I will go into more detail for each of the mechanisms and effects, but one can see that there's a formation of some mental models and a correction of faulty ones. As well, there's a clear difference between the first phase, learning from mistakes, the second phase, which is the daily shift meetings, 3 of them are modeled, the change of teams, and the monthly meetings. However, let's go into detail to view it a bit more precisely. When learning from mistakes happens, a mistake gets triggered, a mistake happens. This triggers the error occurring control mechanism, the control state, which then in fact triggers a process in which it is checked if the mistake that happened actually got proactively registered. If not, it will trigger in hiding error desensitizing, a desensitizing of hiding an error. In the context of our scenario, it will enable, or it will trigger, the young doctor that hides their mistakes to go to a workshop to apply those lessons to his work, and therefore hopefully insensitize him to not hide their mistakes anymore. This is shown through the connection between, this is shown through the weight connection of the weight error occurs and error corrective, which we see in blue, which is slowly starting to become higher, which signifies that the young doctor was proactive about their mistakes. This whole process starts a learning in him, starts the process of working together with the experienced doctor and reflecting upon the mistake that happens. He registered it, he learned about it, he formulated a lesson learned with his superior, and this changed his mental models, both for the right connection, for the succession of task 1 to task 2, it made it more pronounced, better known, and also the wrong connection, in which he would follow task 1 by task 3, got reduced. The second mechanism is the daily shift reflections. Here in red, we have highlighted a state which represents a state that should be followed, that for young Dr. 3, he should follow task 1 by task 2 and not task 1 by task 3. So here we see throughout the daily shift meetings, the first part is always the sharing of mistakes. The second part is always the formulation of a lesson learned and the back propagation of that knowledge. We see that there is an increase in knowledge of the correct task succession, and also a decrease in knowledge, a decrease in likelihood of following the wrong task succession. In detail, we also can see that this daily shift reflections, in the first part, only team mental models are formulated, but they don't influence the young doctor's own mental models. However, in the second phase of the process, as the first phase is sharing and the second phase is the back propagation of knowledge, or like the lesson formulation of lessons learned, we see an actual increase in the corrected knowledge. However, there's also monthly reflections in which also feedback and feed forward and then feedback learning happens. Given feed forward learning is the same as in the daily shift reflections, it is not important to show it here. The team mental models get created in the same way the organizational mental model gets created. However, it is interesting to see that while there's a monthly meeting, some other context variables, like for example, the changing of teams, have a huge influence on the effectiveness on the monthly reflections. We see, for example, that when we have leadership directed restructuring of teams, that the learning effect at the organizational monthly meeting is drastically more pronounced, as in the case where the change of teams didn't happen, and therefore the workers in the team, the young doctors in the team, were less focused on the work. Overall, we can conclude that the model successfully showed emergent behavior reflecting the empirical findings in the discussed literature, confirming its validity. We observed and confirmed for the model that learning from mistakes is a powerful tool for individual learning. We further showed that the simulations show that the daily shift reflections have a constant and robust positive impact on the correction of the mental models, suggesting this tool as the most reliable mechanism to choose. Furthermore, the model as well demonstrated a cultural shift towards a constant learning culture, verifiable by many interacting learning opportunities occurring. And lastly, the model and its results further confirm that the self-modeling approach by Troyer is a suitable approach to formalize the systems model of organizational change, as well as the proposed dynamic systems view of organizations. However, there are some limitations to the research, and further research also is suggested from it. One of the limitations is that the simulation is scenario-bound and only reflects some organizational learning mechanisms. Therefore, a further advanced model could also integrate observational learning for the task-observing doctor, or could integrate counterfactual thinking as a learning and decision mechanism, as proposed in Balquan-Carr and Troyer. Further, a combination with additional computational models in this domain could be added as well to create a more and more holistic representations of organizational transformations. Lastly, the translated mechanisms of this model can be extracted and reused in other related models. Therefore, future research suggests itself in an extension of the proposed model, as well as in the creation of library of computationally translated transformative organizational change mechanisms. Here are the references. And if any questions remain, please tell me. Please let me know.